Good afternoon, ladies and gentlemen. Thank you for being here so numerously. I would like to talk to you about innovative polymers from Kaneka for bonding plastics and hybrid materials. First, some overview of what we are going to talk about is I will say some words about the Kaneka Corporation, some words about Kaneka Belgium, where I'm from, and then about our polymer technology platform we are using. I will go more specific into details for acrylic modified MS Polymer and what they are, and our latest developments in this field will be highlighted. So, Kaneka Corporation is a Japanese company with headquarters in Japan, Tokyo and Osaka. It was founded in 1949. We have around 104 subsidiaries worldwide with around 10,000 people working for Kaneka. We are active in a numerous field of application, not only in chemicals but also foodstuff, synthetic fibers. But I will talk more about the functional plastics, which is my division. Something more about Kaneka Belgium. Kaneka Belgium was actually the first Kaneka subsidiary outside of Japan, and also one of the first Japanese companies outside of Japan in Europe. So we are quite bigger and newer in that field for a Japanese company. We work around with 330 people in 3 different divisions, which we call KNAs, Eperan, and Kaneka MS Polymer. If you have a look at our plant, which is a nice picture from night picture from our plant, very close to the Antwerp harbor, we have 3 different units, production units. One is the impact modifier, which is used for PVC modification mainly. The other one is Eperan, which are actually foamed polyolefins, mainly polypropylene, that can be used for automotive application, for impact resistance, high strength. And the third, and the most novel production unit at Kaneka Belgium is the liquid polymers, and that is what we call MS Polymer. These MS polymers are base resins for high quality sealants, adhesives and coatings. There are numerous applications with this material because we have different grades that can be used in different applications. I listed some examples like a parquet adhesive over here, but also window bonding, bridge sealing, joint sealing, all of these kind of things. More about the chemistry of MS Polymer is simply said, it's a polyether backbone which we silylate at the end. So it's end silylated. That's easier said than done, of course. Kaneka started to do this in 1978 in Japan and were the founder of this technology. They brought this technology and the capability of producing it in Europe in 1996 to Belgium, and we are still producing it here in Belgium. We have a very high degree of capabilities in polymer design. That means we can choose if you make a very long polymer or a very short polymer. That can either be linear or branched. So based on these 4 options, we can make enormous amount of different polymer grades that can serve different segments of the market. A few special types are single-ended, so this is here situated, or special terminate, which we call high strength. Typically, all polymers are telecalic, except a few ones which are single-ended, and that they can be used as a reactive plasticizer in the system. This end captation of silyl groups can be DMS, what we call, or TMS. DMS stands for dimethoxysilyl, it's over here, so dimethoxysilyl, so only 2 reactive groups, or a trimethoxysilyl, which contains 3 reactive groups. Of course, one could realize that with a trimethoxysilyl group, the polymer is more reactive, so you need less catalyst. Something more about the newer grades we have developed is acrylic modified types. So since 1986, Kaneka has developed also acrylic modified types. They were pioneer and still the only exclusive supplier in the market for these acrylic modified types. So it's a physical blend of the polyether backbone, which is silylated, with polyacrylate backbone, which is also silylated. The difference is that it's randomly silylated, this acrylic backbone. Again, here we have the choice between DMS and TMS polymers. these acrylic modified types have some advantages. There are actually three. The biggest advantages is the UV resistance is improved, adhesion to plastics is improved because of the acrylic modification, and higher strength levels can be achieved also. So this is a graph which shows the relative hardness in function of the relative exposure to UV light. And the full blue line is actually a DMS MS polymer, and the dotted blue line is a TMS MS polymer. You could see that the hardness decreases quite rapidly with these standard MS polymers. You can see an increase from going from DMS to TMS. That's purely because you create more siloxane bonds, so which are more UV resistant. But if you then check at the DMS and the TMS acrylic types, you could see a real increase in UV resistance of these type of polymers. Then, concerning high strength and water resistance, these polymers enable us to make novel applications, like a D4 wood adhesive, which in the past, without the acrylic modification, was impossible. So here we used, we call it the Kaneka MA 490, which is one of our highest grade in acrylic modification. And that exhibits very nice results, even with the stringent D4 testing, which is called serial number 3 here, where you have a 7 days curing at room temperature, continue by 6 hours boiling test, 2 hours water immersion, and then you still need to have a tensile strength, a lap shear strength above 4 megapascals, which we have 5.9 still, so quite remarkable. Another advantage of this acrylic modification is the increased adhesion to difficult substrates. When I say difficult, I mean low surface energy substrates like PVC. One example is in LVT flooring, what we call a luxury vinyl tile flooring, which latest years is getting more and more interesting for workers in construction. We did a benchmarking study where we took 8 acrylic dispersion, which are water-based dispersions, and we compared them with 7 MS polymer-based formulations, and we also took one 2-component polyurethane formulation. And we compared the data on peel test on PVC with 2 substrates, a plywood substrate and a cementitious substrate. And there we listed in 3 different curing cycles. The test control test is actually 28 days curing. Test 1 is 20 days curing, continued by 20 days curing at higher temperatures, for instance 50 degrees. And test 3 is the same, but 41 days at 50 degrees, according to the EN 1372 norm. And there we have seen that these MS polymer based formulations all exceed the 1 megapascal, or 1 Newton per square millimeter range, whereas some of the acrylic dispersions fail at these substrates. Also, the highest strength levels are achieved with MS polymer compared to the 2-component polyurethane. So, quite nice results here. This is the same study, but we did it on cushion vinyl, which is more elastic substrate than the luxury vinyl tile. So results are quite comparable, and here again, results are quite nice for MS polymer compared to the acrylic dispersion, and especially if you compare them to the 2-component polyurethane. All these formulations based on MS are 1 component, so you don't need to mix, you don't need to be careful that the mixing is homogeneous, although we have the same strength levels, so advantage for the worker. To conclude this LVT benchmarking study, we have seen also that the curing profile with these MS-based adhesives is very tunable. So that means we have a very strict control of the open time. If we say we want 1 hour open time, it's very well managed by adding the certain catalyst at a certain level. With 2-component polyurethanes, it's sometimes more difficult because it's more dependent on the moisture level of the substrate floor, moisture level of the air. Then the improved adhesion to plastics at increased strengths. There we see that we took some of the difficult substrate like polycarbonate, PMMA, PVC, fiber reinforced plastics, and we checked what is the difference in adhesion strength with SAX 750, which is a high strength MS polymer without acrylic modification, and MA 490 and 90 and 80, which are acrylic modified types. There we see clearly on a difficult substrate like polycarbonate, we see really an increase from going to these high acrylic versions. So they can aid in difficult substrate applications. You have also seen that the type of failure with acrylic types is more pronounced to be cohesive failure, as you see here. So especially on PVC, we see almost full cohesion failure compared to standard MS polymers, where you only have adhesion failure. So nice results also here. We did the same study on dissimilar material bonding, for instance, aluminium to PVC, metal to PVC, steel to PVC. More and more interest also from the automotive market for this lightweight vehicle design. This acrylic modification of MS polymer can support this technology. I listed here the tensile strength in megapascal to the elongation on what we call typical MS polymer products. So the first two here are actually, we call it high strength MS polymer, so not acrylic modified. These two is the low viscous acrylic modified type, and this one is a very high viscous type, which is MA 490, which exhibits clearly the highest tensile strength, but the elongation is still to be undesirable. What we have now developed in Kaneka's lab is a novel polymer design for these acrylic types, which exhibit the following characteristics. So we come very close to the 5 megapascal levels at 500% elongation. So very close to what is commonly requested in automotive market or material bonding market. So we believe these two types, this experimental 1 and 2, could be the future for material bonding of low surface energy. Then the latest developments are actually in low viscous acrylic types. So we call it experimental 3 and 4 here, that exhibit a very low viscosity, but when blended with a suitable acrylic modification, type MS polymer, they exhibit the same characteristics at almost half of the viscosity. Because that's one of the major drawbacks of this acrylic modified MS polymer, is that the viscosity increases quite drastically of this polymer. So that could be a downside for this market, especially in automotive or assembly bonding, that the viscosity is too high. But with the use of these two new grades, we are able to reduce the viscosity and have the same strength levels. So I would like to end this presentation concerning the acrylic modified MS polymer technology, that it's a unique blend technology, and it's exceptional, and it's only produced by Kaneka. It enables formulators to create higher tensile and lap shear strengths. It can increase the weatherability of your seal, and it can improve adhesion to plastics. But with these latest developments, on top of all the above, we can also create higher elongations at these high tensile strengths. And even low viscosity formulations make it possible for a formulator to be more, differentiate them from the market. I would like to end with this slide, that we at Kaneka believe that a good partnership creates great results. So we believe that by working together with our customers, with our end customers, with our suppliers, we create innovation through partnerships. So I would like to thank you for your attention. I listed here our current acrylic modified grades, which are available. If you have any questions, please come by our booth. We are located very close to here at booth 430 in Hall 1. So you're more welcome to join us, have a good discussion, and perhaps join us for a Belgian beer. Thank you.